Hello, and welcome to Sleepy Universe. Whatever day you've had, you can let it go now. There is nothing you need to do, nothing you need to solve. Tonight, we'll take a gentle journey across our cosmic home, the Milky Way. We'll explore 100 quiet facts about its stars, its dust, and its vast, silent mysteries. You don't need to remember any of them. Your only task is to listen and let your mind drift on the currents of the galaxy. So find a comfortable position. Feel your body grow heavy, supported by your bed. Let the weight of the day melt away. Just listen and imagine we are floating, unmoored, in the deep, quiet sea of space, looking back at our own galactic island. Now, let your awareness float up, beyond the clouds, and into the starry veil of the Milky Way. Let's begin. The Milky Way you see arching across the night sky is not a cloud or a mere painting of light. It is the collective glow of hundreds of billions of distant suns, a galactic river of starlight so vast that its light takes tens of thousands of years just to travel from one shore to the other. Let this idea settle gently in your mind. You are not looking at a picture. You are looking at a metropolis of stars, a city of suns. Each tiny, unresolved point of light in that soft, hazy band is not one star, but thousands, millions, layered over one another by the profound depth of space. That gentle, diffuse glow is the combined whisper of countless nuclear furnaces, each burning with its own story, its own planets, its own silent history. And you are living deep within its peaceful suburbs, gazing back toward the brilliant, crowded downtown of your own cosmic home. You are inside the story, looking out at the pages of your own galactic book. Our position in the galaxy is not central, not prominent. We live in the quiet outskirts, in a minor spiral arm known as the Orion Spur. Let yourself feel the gentle humility of this fact. We are not at the heart of the action, not in the bright, dense core where stars crowd together like citizens in a brilliant square. We are out in the galactic countryside, where the stars are more spread out, the space is darker, and the pace is slower. From our quiet street, the Orion Spur, we have a perfect, oblique view of the galaxy's greater structure. We can see the grand spiral arms winding their way around the center. We can see the dark, dusty lanes that weave between them. Our modest location is what grants us this breathtaking, edge-on view of the Milky Way. Our insignificance is our gift. It provides us with the perfect seat to witness the grandeur. The Milky Way is not a static painting. It is a slow, majestic whirlpool, a cosmic dance of stars and gas that completes a single, graceful rotation every 225 million years. Consider the slowness of this dance. A single galactic year, one full rotation, is a time frame that dwarfs all of human history. The last time our solar system was in this particular spot in its orbit, the continents of Earth were joined as one, and the first dinosaurs were only just beginning to walk the land. All of our civilizations, our wars, our art, our love, every human life that has ever been lived has occurred in less than a fraction of a single galactic breath. This great, slow turning is the rhythm of our cosmic home, a rhythm so deep and so slow we cannot perceive it, only know that we are carried within it, peacefully, silently, on a journey around a center we cannot see. At the very heart of the Milky Way, in the constellation of Sagittarius, lies a silent, invisible giant, a supermassive black hole named Sagittarius, a star. Let your mind drift towards the center of our galaxy, past the glittering stars, beyond the glowing nebulae, behind the great dark curtains of cosmic dust. There resides a gravitational anchor. Its mass is 4 million times that of our Sun, all collapsed into a point of such immense density that it warps the very fabric of space and time around it. It is not a monster, it is a sleeper, a dormant engine whose presence is felt only by the frantic, whirling dance of stars caught in its irresistible grip. The entire majestic spinning wheel of our galaxy revolves slowly and silently around this slumbering heart of darkness. The dark patches and rifts you see splitting the luminous river of the Milky Way are not empty voids. They are dark nebulae, immense cold clouds of microscopic dust grains, so thick and dense they block the light from the stars behind them. See those dark streams, like black ink spilled into the milk of the stars? They are not absences, they are presences. They are clouds of cosmic soot, made of carbon and silicate minerals, finer than any powder. They are the raw, unformed potential of the galaxy. Within these dark wombs, shielded from the harsh light of other stars, gravity slowly, patiently, pulls these dust grains together. It is here, in the deepest shadows, that the first whispers of new stars and new worlds begin to stir. The darkness is not an end, it is a cradle. Our galaxy is not alone. It is part of a small gravitational family called the Local Group, a collection of over 50 galaxies, all drifting together through the vast intergalactic void. Expand your sense of home beyond the Milky Way. We are part of a neighborhood. Our closest companions are the Andromeda Galaxy, a spiral even larger than our own, and the Triangulum Galaxy, a smaller, beautiful pinwheel. There are dozens of smaller dwarf galaxies, like faithful satellites orbiting the larger ones. This entire group, millions of light years across, is a single, isolated island in the grander ocean of the cosmos. We are not a solitary wanderer. We are part of a cosmic archipelago, a family of galaxies, all bound by the gentle, unseen strings of gravity. The Milky Way and the Andromeda Galaxy are on a slow, inevitable course toward each other, destined to meet and merge in a graceful, billion-year-long embrace. Do not imagine a violent crash. Imagine a slow, cosmic dance. In about 4.5 billion years, our galaxy and our great sibling, Andromeda, will begin to feel each other's pull more strongly. They will draw closer, their gravitational fields intertwining like slow-motion threads. They will pass through one another, their stars so far apart that they will rarely, if ever, touch. Over billions of years, they will swing past, then fall back again and again, until their separate identities are lost and they coalesce into a single new, larger galaxy, most likely a quiet, elliptical galaxy. It is not an end, but a transformation, a galactic reunion written in the stars. The galaxy is filled with a faint, thin gas, the interstellar medium. This is the primordial breath of the Milky Way, the raw material from which everything is born. The space between the stars is not a perfect vacuum. It is a ghostly, thin atmosphere. A single molecule might float for miles before meeting another. This gas, mostly hydrogen and helium, is the galaxy's reservoir. It is the stuff from which stars condense, like droplets forming from a mist. When you look up at the night sky, you're looking through this ethereal ocean. It is invisible to our eyes, but it is there, the cosmic air we swim in, the source of all future light and life in our galactic home. The Milky Way has a vast, spherical halo of ancient stars and mysterious dark matter that envelops the entire bright disk, a ghostly aura that contains most of the galaxy's mass. Imagine the shining spiral disk of our galaxy. Now, envision a giant, invisible sphere surrounding it, a cosmic aura that extends far, far beyond the last visible star. This is the galactic halo. Scattered within it are the oldest stars in the galaxy, ancient red dwarfs and globular clusters that formed billions of years before our sun was even a dream. And permeating it all is dark matter, an unknown substance that does not emit light, but whose gravitational pull is the true, unseen skeleton of the Milky Way. It is this dark halo that holds our galaxy together, an immense, invisible hand cradling the shining disk of stars. The stars in the Milky Way are not all the same age. There are ancient reddened stars that are nearly as old as the universe itself. And there are brilliant, blue, newborn stars that have just ignited. The galaxy is a living chronicle of time. In its halo and its core, you will find ancient stars, population 2 stars. They are frugal, burning slowly for billions of years, their light tinged with the red of great age. They remember the galaxy's wild youth. Then, in the spiral arms, you find the young, profligate stars, population 1. They are brilliant, blue and hot, born from the rich gas and dust of the galactic disk. They live fast and die young in spectacular supernovae. Our own sun is a middle-aged star, a member of the younger population, born from the ashes of generations of stars that lived and died before it. Our solar system is moving through the galaxy not in a flat, even plane, but with a slight, bobbing motion, like a boat on a gentle cosmic sea. As we orbit the galactic center, we do not travel on a perfectly flat track. The collective gravity of the stars and gas in the disk tugs at us, causing our solar system to oscillate slowly up and down, north and south of the galactic plane. It takes us about 60 million years to complete one full bob, moving above the plane, diving below it, and returning. It is a slow, rhythmic rocking, a celestial lullaby on a timescale so vast that during the last time we were at this height above the galaxy, the age of dinosaurs was reaching its peak. We are forever riding this gentle galactic wave. The Milky Way is constantly being rained upon by small dwarf galaxies, which are slowly being torn apart and absorbed by our galaxy's far greater gravity. Our galaxy is a gentle giant, still growing. Faint, small streams of stars, the remnants of dwarf galaxies, are being stretched out by our gravity, wrapping around the Milky Way in great stellar rivers. These are the final dissolving breaths of smaller galactic systems that ventured too close. In billions of years, they will be completely assimilated, their stars becoming part of the Milky Way's halo. It is a slow, cosmic process of consumption and growth, a silent gravitational feast happening all around us, invisible to the eye, but known to the telescopes that peer into the depths. The spiral arms of the Milky Way are not fixed structures made of the same stars, but are patterns of density, like waves moving through a crowd of people. This is a beautiful and subtle truth. The majestic spiral arms are not permanent arms of stars, like the spokes of a wheel. They are spiral density waves, regions of compressed gas and enhanced gravitational pull that move through the galactic disk. Stars and gas clouds move into the wave, slow down, and are compressed, triggering the birth of new, bright stars. Then, they move out again. The arms are a self-perpetuating pattern, a stellar traffic jam that lights up with brilliant young stars, while the stars themselves continuously flow through it. The pattern is permanent, but the participants are always changing. The Milky Way is a source of a faint, constant radio hum, the combined whispers of countless natural cosmic processes, from the spin of cold hydrogen gas to the faint afterglow of dead stars. If you could hear the galaxy, it would not be with the crackle of a fire, but with a deep, pervasive hum, a symphony of low-frequency radio waves generated by the slow spin of hydrogen atoms in the void, by the frantic pulses of distant pulsars, by the quiet shiver of gas clouds. It is the background noise of a living galaxy, a sound far below what human ears could ever perceive, but one that fills the space between the stars. It is the galaxy's own lullaby, broadcast on a frequency of silence. We will never be able to see a full picture of our own galaxy from the outside. Our view will always be from within, a beautiful, partial perspective. All the stunning images you have seen of spiral galaxies like Andromeda or the Whirlpool Galaxy are pictures of what our own Milky Way might look like. But we, trapped inside its disk, can never take such a self-portrait. Our understanding is built from painstaking measurements, from mapping the positions and distances of stars, from peering through the dust with infrared eyes. Our view is one of immersion, not overview. We are like a single cell in a vast body, trying to comprehend the shape of the whole from our tiny internal vantage point. It is a reminder that some beauty is known not by sight, but by deduction and wonder. The galaxy is populated by stellar ghosts, neutron stars, and black hole, the dense, dark remnants of massive stars that died in supernova explosions long ago. For every brilliant, shining star you see, there are countless dark, departed companions. When a massive star dies, it can leave behind a neutron star, a city-sized object with the mass of a sun so dense a teaspoon of it would weigh 1 billion tons. Or it can collapse into a stellar mass black hole. These remnants are scattered throughout the galaxy, invisible, silent, and dark. They are the ghosts of stellar giants past, drifting through the cosmos, their presence only betrayed when they pull gas from a companion star or warp the light of a star behind them. The galaxy is a graveyard, as much as it is a nursery. The Milky Way is warped, its outer disk bent and twisted like the brim of a soft hat, likely by the gravitational influence of a passing dwarf galaxy or the ongoing pull of the Magellanic Clouds. The galaxy is not a perfect, flat frisbee. Its outer edges, particularly the gaseous disk of hydrogen, are warped. One side of the disk curves upward, the other downward, creating a gentle, cosmic twist. This is likely the lasting impression of a gravitational encounter, a close pass by a smaller galaxy billions of years ago, a gentle tug that left a permanent, graceful deformation in the fabric of our galaxy. It is a fossil record of a past dance, a subtle imperfection that makes our home unique. The light pollution from our cities has robbed most of us of the true, overwhelming spectacle of the Milky Way, a sight that was once a universal human inheritance. For nearly all of human history, the Milky Way was a dominant feature of the night sky, a brilliant, detailed, and awe-inspiring cloud of light that cast shadows on the ground. Today, for most people on Earth, it is hidden behind a veil of artificial orange glow. The profound connection to our cosmic home has been dimmed. But the galaxy is still there, just as bright, just as magnificent, waiting patiently behind the glare for us to simply look up from our own light and remember our place in the vast, starry whole. The Milky Way is, statistically, almost certainly filled with worlds. Thousands of exoplanets have already been discovered, suggesting that planets are a common, if not universal, feature of star formation. Every star you see is a sun, and around most of those suns there are likely worlds. Rocky planets like Earth, gas giants like Jupiter, ice giants like Neptune. The galaxy is an archipelago of potential islands, countless worlds orbiting in the quiet dark. Some may be barren, some may be shrouded in ice, some may be boiling hellscapes, and perhaps around a stable, long-lived star, in the gentle liquid water habitable zone, there is a world with its own skies, its own seas, and its own quiet, sleepy mysteries. You are made of the Milky Way, the iron in your blood, the oxygen in your lungs, the calcium in your bones. All of it was forged in the hearts of stars that lived and died in this galaxy long before the sun was born. This is the final and most intimate fact. You are not just an observer of the galaxy. You are a part of it. You are its product. The heavy elements that form your body were created in the nuclear furnaces of massive stars. When those stars ended their lives in colossal supernova explosions, they seeded the galactic gas with these elements. That gas later coalesced into our Sun and our Earth, and eventually into you. You are the galaxy's way of knowing itself. You are a collection of ancient stardust assembled into a conscious form, lying in a bed on a small planet, contemplating the vast, beautiful, and silent home that created you. There is a place in the halo of the Milky Way where a sphere of 1,000,000 stars orbits as one, a globular cluster, a stellar beehive so dense that the night sky from a planet within it would be a perpetual star-drenched twilight. Let your mind wander to this ancient structure. Globular clusters are among the oldest objects in the galaxy, relics from its violent infancy. Imagine 1,000,000 suns, ancient and reddened, packed into a sphere so tight that the nearest star in the sky would be 100 times closer than our own Alpha Centauri. The sky would not be black. It would be a tapestry of continuous, overlapping starlight, with a central core so brilliant it would cast shadows. These are the grand retirement communities of the galaxy, where stars live out their immensely long lives in close, silent company. The galaxy is not silent. It sings a song of gravity and motion, a melody played on the strings of space-time. Though our human ears are not tuned to hear its frequency, every massive object in the galaxy, every star, every planet, every black hole, as it moves, creates ripples in the fabric of space-time itself. These are gravitational waves. The slow, stately dance of a binary neutron star system generates a constant low hum. The merger of two black holes rings the galaxy like a bell. This symphony is playing all around us, a cosmic vibration that passes through our bodies, through the Earth, completely unnoticed. The galaxy is alive with the music of the universe, a silent song written in the language of gravity. Our solar system is surrounded by a vast, protective bubble, the heliosphere, carved out by the solar wind, shielding us from the harsh interstellar radiation of the galaxy. As you rest, you are nestled within a protective cocoon. The sun constantly exhales a stream of charged particles, the solar wind. This wind pushes against the thin interstellar medium of the galaxy, creating a bubble that extends far beyond Pluto. This is our heliosphere. It is a shield, deflecting and filtering the cosmic rays that stream between the stars. You are living inside a temporary pocket of calm, a stellar haven created by our sun, a buffer against the raw galactic environment. The dust of the Milky Way is not just dark, it can also glow. Emission nebulae are vast clouds of gas, set alight by the intense ultraviolet light from newborn, massive stars within them. Within the spiral arms, the galaxy creates its own stained glass windows. An emission nebula, like the Great Orion Nebula, is a cosmic nursery that also becomes a cathedral of light. The fierce young stars flood the surrounding gas with so much energy that it causes the gas to fluoresce, to glow with its own brilliant light. Reds from hydrogen, blues from oxygen, greens from sulfur. These nebulae are the galaxy's art, painted on the canvas of space with the brush of atomic physics. They are the brilliant, short-lived blossoms in the galactic garden. The Milky Way has a past marked by violence and cannibalism. It grew to its current size by consuming smaller, dwarf galaxies throughout its long history. Our galaxy is a product of its mergers. The smooth, majestic spiral we see today was built over billions of years by the gentle, gravitational consumption of dozens of smaller galaxies. The evidence is written in the stellar streams of the halo, the ghostly, stretched-out remains of these galactic meals. We are the product of a peaceful, cosmic consolidation. The stars from those devoured galaxies now mingle with our own, their different chemical signatures telling astronomers the story of the Milky Way's long and quiet feasts. There are stars in the Milky Way that do not belong to it. They are hypervelocity stars, ejected from the galactic core by immense gravitational forces, destined to fly alone into the intergalactic void. Imagine a star flung from the very heart of the galaxy. The immense gravity of the central black hole can, in a complex gravitational dance, slingshot a star outwards at such tremendous speed that it can escape the Milky Way's pull entirely. These are runaway stars, solitary travelers on a one-way journey into the cold, immense darkness between galaxies. They carry with them the memory of their violent birth, destined to grow old and die in the ultimate loneliness of intergalactic space. The galaxy has weather. There are winds, the collective output of stellar winds and supernova explosions, and there are storms like the turbulent regions where gas is shocked and compressed. The space between the stars is not always calm. There is a galactic climate. The combined exhalations of billions of stars create a slow, pervasive wind. When a massive star dies in a supernova, it sends a shockwave, a tsunami of energy, rippling through the interstellar medium for hundreds of light years, compressing gas clouds and triggering the birth of new stars. The galaxy has its own seasons of creation and destruction, its own weather patterns on a scale so vast we can only see them from a great distance. The very center of the galaxy, within just a few light years of the black hole, is a crowded, frenetic place where stars orbit at a significant fraction of the speed of light. At the heart of the Milky Way, the rules of calm are broken. In the intense gravitational field of Sagittarius, a star, stars are whipped around on incredibly tight, frantic orbits. Some complete a full orbit in just a few Earth years, moving at thousands of kilometers per second. It is a stellar racetrack, a region of extreme physics where space and time are stretched to their limits. This frantic dance, observed by astronomers, is how we know for certain of the black hole's presence, the only thing with enough mass to make stars move like that. The Milky Way is a barred spiral galaxy, and that central bar is slowly rotating, a great, solid-like structure of stars turning independently within the larger galactic disk. The center of our galaxy is not a static bulge. It is a rotating bar, a long, dense collection of stars that turns as a single grand unit. This rotating bar acts like a great mixer, churning the inner galaxy, funneling gas towards the center and helping to sustain the spiral arms. Its slow, steady rotation sets the rhythm for the dynamics of the entire inner galaxy, a slow cosmic engine driving the structure of our home. We are made of the elements forged in the Milky Way, but the hydrogen in our bodies, the simplest and most abundant element, is primordial, dating from the Big Bang itself. Consider the water in your body. Each molecule of H2O contains 2 atoms of hydrogen. Those hydrogen atoms are the oldest thing you will ever touch. They were created in the first few minutes after the Big Bang, over 13 billion years ago. They have been part of the interstellar medium inside gas clouds, perhaps part of many stars before our sun, and now they are part of you. You carry the universe's most ancient atoms within you. You are a living repository of cosmic history. The galaxy is mapped not just by light, but by the cold, dark clouds of molecular hydrogen and complex carbon-based molecules, the building blocks of life drifting between the stars. The dark nebulae are more than just dust. They are cold enough for atoms to link together into molecules. Within these frigid dark clouds, simple molecules like molecular hydrogen form, along with more complex organic molecules, the precursors to the chemistry of life. These clouds are the galaxy's frozen grocery stores, stocked with the raw ingredients for planets and, potentially, living organisms. The seeds of life are sown in the coldest, darkest places of the galaxy. The Milky Way's magnetic field is a weak but pervasive force, threading through the entire galaxy, guiding cosmic rays and influencing the shape of interstellar gas clouds. An invisible, fragile web of magnetism stretches throughout the disk of the galaxy. It is 1 billion times weaker than a common fridge magnet, but across light years, its influence adds up. This magnetic field guides the paths of high-energy cosmic rays and helps to shape and structure the vast nebulae. It is the galaxy's subtle, invisible skeleton, a force that gently sculpts the interstellar medium without ever being seen. There is a class of stars called blue stragglers that appear mysteriously young in ancient star clusters, likely rejuvenated by stellar collisions or vampiric theft of fuel from a companion. In the ancient globular clusters, where all stars were born at the same time billions of years ago, astronomers find a paradox. Brilliantly blue, hot, young-looking stars. These blue stragglers defy the simple aging of the cluster. They are believed to be stars that have undergone a cosmic revival, either by colliding and merging with another star, creating a new, more massive and hotter star, or by slowly stealing hydrogen fuel from a binary companion, extending their own lives. They are the galaxy's exceptions, the stars that found a way to cheat time. The sun's path through the galaxy is not a simple circle. It is a slightly wobbly, epicyclic loop, a gentle weave through the local stellar neighborhood. As our sun orbits the galaxy, it does not move in a perfectly smooth curve. The combined gravitational pull from the spiral arms, the central bar, and the local density of stars gives its motion a slight wobble, a gentle rocking back and forth as it travels. It's a path akin to a car moving along a slightly bumpy road. This ensures our solar system experiences a changing galactic environment over millions of years, a slow cosmic journey with a subtle rhythmic sway. The Milky Way is full of failed stars, brown dwarfs, objects too massive to be planets, but not massive enough to ignite sustained nuclear fusion in their cores. They glow faintly with a dim, residual heat. For every shining star, there may be many of these dark, wandering bodies. Brown dwarfs are the elusive, in-between objects of the galaxy. They are Jupiter-like, but dozens of times more massive. They may briefly fuse a rare form of hydrogen, but then they cool and fade, radiating only a deep infrared warmth. They are the galaxy's hidden population, the dark, cold embers scattered throughout space, invisible to our eyes, but known by the heat they leave as a signature. The galaxy is a source of faint, mysterious, and powerful radio bursts that last only milliseconds. Their origin is one of astronomy's great puzzles, possibly involving highly magnetized neutron stars. From the deep reaches of the Milky Way and beyond come incredibly brief, intensely powerful blasts of radio waves. These fast radio bursts, FRBS, last for a fraction of a blink of an eye, but in that moment, they can outshine entire galaxies. Some of them repeat, others are one-off events. While some come from other galaxies, others have been traced to within our own, likely from magnetars, neutron stars with unimaginably powerful magnetic fields. They are the galaxy's sudden, unpredictable flashes, like a cosmic lighthouse spinning its beam across the universe for a single brilliant instant. The Milky Way's disk is not uniformly thick. It thins out towards the edges, its stellar population growing sparser, like a city gradually fading into countryside and then into wilderness. The galactic disk is like a pair of cymbals, clapped together at the center and thinning towards the rim. In the central regions, the disk is thousands of light years thick, dense with stars and gas. As you travel outwards towards the galactic hinterlands, the disk becomes thinner, the stars more spread out, until you reach the very edge, where the last lonely stars mark the final frontier of the Milky Way's main structure. We live in a region of moderate thickness, in the galactic equivalent of a vibrant suburb. The history of the Milky Way is being uncovered by galactic archaeology, the study of the motions and chemical compositions of millions of individual stars to piece together our galaxy's formation story. By carefully measuring the age, composition, and motion of stars, astronomers are like archaeologists sifting through the ruins of an ancient civilization. Stars born together in the same cloud share a chemical fingerprint. By mapping these fingerprints and trajectories, we can trace stellar families and identify which stars are native to the Milky Way and which are immigrants from devoured dwarf galaxies. It is a slow, meticulous process of reading the genealogy of the stars to write the biography of our galaxy. There are planets in the Milky Way that are not bound to any star. Rogue planets, ejected from their solar systems, drifting forever in the cold, dark interstellar space. For every star that holds planets, there may be worlds it could not keep. Gravitational interactions can fling a planet out of its solar system, sending it on an eternal journey through the blackness between the stars. These are rogue planets, dark and frozen, with no sun to warm them. Their skies would be perpetually black, punctuated only by the distant, unchanging stars. They are the galaxy's lonely orphans, the ghost ships sailing the silent sea of night. The Milky Way, for all its grandeur, is just one of an estimated 2 trillion galaxies in the observable universe. A single, beautiful specimen in a cosmic collection of unimaginable size. Hold this final thought for tonight. Our entire home, with its hundreds of billions of stars, its vast spiral arms, its ancient halo, is one of countless such islands. The Hubble Deep Field image revealed a tiny, seemingly empty patch of sky, contained thousands of galaxies, each with billions of stars of their own. The scale is beyond human comprehension. It is a humbling, and yet a strangely comforting thought. Our galaxy, with all its mysteries and wonders, is part of a whole that is so much greater, a universe of limitless beauty and silence. The galaxy's spiral arms are not just collections of stars, but wave fronts of star formation, where the compression of gas triggers the birth of new stellar generations, lighting up the structure from within. The spiral arms are the galaxy's most active creative zones. As the density wave passes through, it squeezes the interstellar gas, much like a hand squeezing a sponge. This compression triggers gravitational collapse, and vast dark molecular clouds begin to fragment into protostars. The arms are not defined by the stars that live there permanently, but by the brilliant, short-lived, massive stars that are born there and light up the structure before dying young, their explosions further fueling the cycle of creation and destruction. The Milky Way's halo contains not only ancient stars, but also vast reservoirs of incredibly hot, ionized gas, detected only by its faint X-ray glow, a shroud of million-degree plasma. Enveloping the visible galaxy is a massive, seething atmosphere of ultra-hot gas. This corona is so tenuous that a single cup of it would contain only a few atoms, but it is so hot it glows in X-rays. This gas is a fossil from the galaxy's formation, or perhaps accumulated from the intergalactic medium over billions of years. It is a reminder that what we see in visible light is only a small part of the galaxy's total substance. It is embedded in a giant, invisible, and incredibly hot atmosphere. The solar system is currently moving through a region of space known as the local interstellar cloud, a slight densification in the galactic medium, a gentle patch of slightly warmer, partly neutral gas. Our journey through the galaxy is not through a perfect uniform vacuum. We are currently passing through a small, localized cloud of interstellar material about 30 light-years across. It is a wisp of slightly denser gas, a gentle breeze in the galactic environment. In tens of thousands of years, we will have moved through it and into another region of space with a different density and composition. We are always sailing through the changing seas of the interstellar medium. The dust grains in the Milky Way are not spherical. They are thought to be elongated, needle-like particles that align with the galaxy's magnetic field, polarizing the starlight that passes through them. The tiny particles that make up the dark nebulae are shaped by the galaxy's invisible forces. They are likely elongated, like microscopic needles. The weak galactic magnetic field causes these tiny needles to align, like compasses. This alignment polarizes the starlight that passes through the dust clouds, subtly changing the direction of its vibration. By measuring this polarization, astronomers can map the otherwise invisible magnetic field of the galaxy, reading the secrets of its structure in the faint twist of starlight. There is a snow line in the galaxy, a distance from any star within which water ice cannot permanently exist in the vacuum of space, sublimating directly into gas. Beyond this line, ice is stable, coating dust grains and building icy worlds. Around every star, there is a boundary in its protoplanetary disk. Inside this line, it is too warm for water ice to survive. It turns directly from solid to gas. Outside this line, it is cold enough for water ice to be stable. This snow line is a fundamental division in planet formation. Inside it rocky planets like Earth form. Outside it, the abundance of solid ice allows for the rapid growth of the massive, icy cores that go on to become gas giants like Jupiter and Saturn. The architecture of solar systems is dictated by this simple thermal frontier. The Milky Way is a source of diffuse, faint gamma-ray glow, emanating from the interactions of cosmic rays with atomic nuclei in the interstellar medium, a perpetual high-energy background shimmer. The galaxy glows not just in visible light, but in the most energetic form of light, gamma rays. This glow is not from discrete sources, but is a diffuse fog created when high-speed cosmic rays, atomic nuclei accelerated to near light speed, collide with the slow-moving atoms of the interstellar gas. These collisions produce pions, which quickly decay into gamma-ray photons. The entire galactic disk shimmers with this faint, lethal radiation, a testament to the violent particle accelerators, supernova remnants scattered throughout its arms. The concept of a year is planetary, but the galaxy has its own grand cycle, the galactic year, which is 225 million Earth years long, framing time on a scale that encompasses the rise and fall of species. All of human history is a blink in a single galactic day. The galactic year, the time it takes for the Sun to orbit the center of the Milky Way, is a calendar for the cosmos. The dinosaurs arose, ruled the Earth, and were wiped out in less than one full galactic orbit. The entire story of complex life on our planet has unfolded within a small fraction of a single galactic year. It is the ultimate long-term clock, measuring time in units of cosmic rather than terrestrial seasons. The Milky Way's rotation is not a rigid turn. It exhibits differential rotation, meaning stars at different distances from the center complete their orbits at different rates, like cars on a multi-lane highway. The galaxy does not spin like a solid wheel. Stars closer to the center orbit much faster than those in the outer regions. This differential rotation is what winds up the spiral arms and is a key feature of all spiral galaxies. Our Sun, in its suburban location, moves at a different pace than a star near the core or one at the very edge. We are all on the same ride, but we are not all moving at the same speed, each star tracing its own independent, graceful ellipse around the galactic center. The galaxy is filled with the faint, cold skeletons of dead stars, white dwarfs, the Earth-sized cores of expired sun-like stars, slowly cooling to blackness over trillions of years. The fate of most stars, including our Sun, is not a violent supernova, but a quiet fading. They will shed their outer layers and leave behind a white dwarf, a stellar ember made mostly of carbon and oxygen, incredibly dense and no longer producing energy. It will simply glow with leftover heat, slowly cooling down over timescales longer than the current age of the universe. The galaxy is filled with these darkening cinders, the silent, final states of the majority of its stellar population. You are connected to the galaxy by the mere act of looking up. The photons of starlight that land on your retina are physical messengers that have traveled across the void, completing a journey that began years, centuries, or millennia ago. When you gaze at a star, you are not a passive observer. You are the destination. A tiny particle of light, a photon, has journeyed through the emptiness of space for an immense duration. It has not been scattered or absorbed. It has traveled in a perfectly straight line at the universe's ultimate speed, on a mission to deliver a single piece of information to you: that it was emitted from a sun, and that it ended its cosmic journey by interacting with a molecule in your eye, creating a signal in your brain that you interpret as beauty and wonder, is one of the most intimate and profound connections possible in the cosmos. You are, in that moment, the universe perceiving itself. The Milky Way is not a perfect flat disk, but warps gently at its edges, like a piece of paper held loosely in your hand. A subtle bend caused by the gravitational tug of its satellite galaxies and the dark matter halo. Imagine the entire galaxy, this vast city of stars, as having a gentle, graceful curve at its very outskirts. It is a slow, cosmic bending, a warp that takes millions of years to complete a single oscillation. This is the lasting impression of a gravitational dance with the Magellanic Clouds and the pervasive pull of the invisible dark matter that cradles us. Even our grand home is not rigid, but fluid, swaying to a music we cannot hear. Our galaxy sings a bass note of gravity, a frequency too low for any ear to hear, generated by the slow, orbital dance of its billions of stars around the common center of mass. Beneath the silence, there is a vibration. The combined motion of every star, planet, and cloud of dust creates a gravitational waveform, a resonance that fills the galaxy. It is a sound with a wavelength of light years, a hum so deep and low it is more a tremor in space-time than a noise. This is the true voice of the Milky Way, a single sustained chord played on the strings of the universe, the background music to our silent, starry night. There are places in the galaxy where stars are born not in isolation, but in vast, bustling clusters, emerging from the same cosmic womb and shining their brief, brilliant lives together before slowly drifting apart over eons. Think of a stellar nursery, not as a quiet cradle for one star, but as a grand, celestial hospital where thousands of suns are born at once. They ignite in a relative flash, lighting up their natal cloud with fierce, ultraviolet light. For millions of years, they are a close-knit family, their gravitational bonds tight. But as they age, the gentle, relentless tides of the galaxy will pull them apart, scattering them across the spiral arms, each going its separate way, their shared origin a faint memory in their chemical composition. The galaxy's center harbors not one, but thousands of smaller black holes, stellar remnants drawn to the core over billions of years, now swirling in a silent, dark retinue around the central, supermassive giant. Journey to the heart of the galaxy, past the brilliant, frantic stars. There, in the tight space around Sagittarius, a star, lurks a congregation of darkness. Thousands of stellar mass black holes, the ghosts of massive stars, have been pulled into the core over the eons. They orbit the great central black hole, a swarm of invisible predators in a cosmic arena. their presence only betrayed by their X-ray glow as they occasionally pull gas from a companion star. It is a silent, dark court surrounding a sleeping king. The solar system is plowing through the interstellar medium, and the heliosphere that surrounds us is shaped not like a sphere, but like a teardrop with a long, trailing tail, a cosmic wake marking our path. As we journey around the galaxy, we do not move through a perfect void. We sail through a thin, interstellar breeze. The pressure of this breeze, combined with our own motion, pushes the protective bubble of our heliosphere into a shape like a teardrop, blunted and rounded at the front, where we meet the wind, and stretching out into a long, trailing tail behind us, like the wake of a ship on a dark, cosmic ocean. We are always leaving a mark, a temporary signature in the galaxy. The very dust of the galaxy scatters blue light more effectively than red, a process called interstellar reddening, which makes distant stars appear redder and dimmer, as if viewed through a gentle cosmic veil. The galaxy has its own filter. The tiny dust grains that fill space are like countless minute prisms. They scatter the short blue wavelengths of starlight, letting the longer, redder wavelengths pass through more easily. This is why a distant star, which might be brilliant blue up close, appears as a dim, ruddy point to us. We are seeing the universe through a haze of cosmic dust, a perpetual gentle sunset that tinges everything with the warm color of twilight. The Milky Way has a faint, hot corona of gas, an atmosphere of ionized plasma that extends for hundreds of thousands of light years, a final, tenuous whisper of our galaxy's presence in the void. Enveloping the entire bright disk and halo is a giant, invisible atmosphere, a corona of million-degree gas, so thin it is a better vacuum than any we can create on Earth, yet so vast it contains the mass of millions of suns. It glows not in light, but in faint X-rays, a shimmering, ultra-hot fog that represents the very outermost breadth of the Milky Way, a final fading boundary between our island universe and the profound emptiness between galaxies. Some of the stars you see are not true members of the Milky Way, but interlopers from the Magellanic Clouds, caught in a temporary gravitational embrace before they continue their journey. Look up at the starry band. Among its countless points of light, there may be visitors. Stars that were born in the large or small Magellanic Cloud, our orbiting dwarf galaxy companions, have been gravitationally stripped away and are now passing through our own galaxy. They are cosmic tourists, just visiting our stellar metropolis before the dynamics of the local group eventually pull them away on another path. The sky is not a static family portrait. It is a gallery with rotating exhibits. The force that holds the galaxy together, gravity, is the same gentle force that holds you in your bed tonight. A universal tether connecting the vast cosmos to your quiet, resting form. The same invisible attraction that keeps the Earth orbiting the Sun and the Sun orbiting the galactic center is acting upon you right now. It is the force that gives you weight, that holds you gently but firmly to the surface of your world. There is no difference between the gravity that governs the dance of galaxies and the gravity that makes your body feel heavy and relaxed against the mattress. You are, in this very real sense, physically connected to the entire Milky Way. The galaxy is filled with the faint, cold echoes of dead stars, the expanding shells of supernova remnants, which glow for thousands of years as they dissipate their energy back into the interstellar medium. When a massive star dies, it does not vanish. It gives one final, brilliant gift. The shockwave from its explosion travels outwards for millennia, sweeping up interstellar gas and dust into a vast glowing shell. These remnants, like the Crab Nebula, are celestial ghosts, their intricate filaments shining with the energy of the explosion that created them. They are the recycling plants of the galaxy, scattering newly forged heavy elements back into the void, where they will, one day, form new stars, new planets, and perhaps new life. There is a theoretical boundary, a galactic habitable zone, a region within the galaxy where conditions are just right for complex life to arise, not too close to the violent center, not too far out in the metal-poor outskirts. Our place in the galaxy may not be an accident. Too close to the center, and planetary systems would be bombarded by radiation and destabilized by gravitational encounters. Too far out in the galactic hinterlands, and there would not be enough heavy elements to form rocky planets. We live in a Goldilocks zone on a galactic scale, a quiet, stable neighborhood with just the right ingredients. The galaxy, too, has its own zones of comfort and danger. The Milky Way is constantly gaining new material as pristine hydrogen gas from the intergalactic medium slowly rains down upon it, providing fresh fuel for future generations of stars. The galaxy is still growing. It is not a closed system. From the vast voids between galactic clusters, a slow, gentle rain of primordial gas falls onto the Milky Way. This is hydrogen and helium that has never been inside a star, the raw, unprocessed material of the Big Bang. This continuous accretion is the galaxy's way of breathing in, of taking in new fuel to keep the great engine of star formation running for trillions of years to come. The oldest stars in the galaxy, found in the halo and globular clusters, are metal poor, meaning they contain almost nothing but hydrogen and helium, a pristine record of the universe's youth. The first stars to form in the Milky Way were pure. They condensed from gas that had not yet been enriched by the death of previous stars. They contain only the simplest elements: hydrogen, helium, and a trace of lithium. To an astronomer, these ancient metal-poor stars are living fossils. Their spectrum is a simple, clean recipe compared to the complex chemical signature of younger stars like our Sun. Studying them is like reading the first simple chapter of our galaxy's long and complex biography. The spiral arms are not just patterns of light, they are patterns of sound, density waves that propagate through the galactic disk like slow-motion sonic booms, triggering star formation in their wake. The beautiful spiral arms are a kind of frozen music. They are density waves, analogous to the sound waves that travel through air. As this wave of compressed space-time moves through the galactic disk, it doesn't carry the stars with it permanently. Instead, stars and gas flow into the wave, are compressed, and then flow out again, like cars entering and leaving a traffic jam. The wave itself is the pattern, the melody, and the brilliant new stars it triggers are the notes it plays on the interstellar medium. Our view of the Milky Way is a mosaic of different times. The light from stars in the same constellation may have left them decades, centuries, or millennia apart, presenting a single picture composed of countless different moments. When you look at the constellation of Orion, you're not seeing a group of stars as they are now. The light from Betelgeuse left over 500 years ago. The light from Rigel began its journey around 860 years ago. You are seeing each star in a different year of its long life, a different point in its history. The sky is not a snapshot, but a layered portrait, a collage of whens, as much as it is a map of wheres. It is a tapestry woven from threads of time itself. The galaxy contains fossil streams of stars, the ghostly, stretched-out remnants of dwarf galaxies that were torn apart by our galaxy's gravity billions of years ago. Wrapping around the Milky Way are faint rivers of stars, so diffuse they are almost invisible. These are tidal streams, the final dissolving forms of small galaxies that ventured too close. Over billions of years, our galaxy's gravity has stretched them out, smearing them across the halo in great stellar currents. They are the galactic equivalent of archaeological dig sites, their stars telling the story of a long-ago merger, a silent testament to the galaxy's growth through cannibalism. The vacuum of space within the galaxy is not empty. It contains a few hundred atoms per cubic meter, a diffuse medium that would be considered an ultra-high vacuum on Earth. But across light years, it adds up to immense clouds. The void is not a perfect nothingness. In the space between stars, there are a few hundred atoms in a volume the size of a sugar cube. It is a vacuum far beyond anything we can create in a lab. But this tenuous gas is the raw material of everything. Across the immense volumes of interstellar space, these few atoms per meter accumulate into clouds massive enough to form 10,000 suns. The grandest structures begin with the most sparse and humble beginnings. The Milky Way's magnetic field, though incredibly weak, is thought to be generated by a galactic dynamo effect caused by the complex motions of conducting gas in the galactic disk. The invisible magnetic web that threads our galaxy is a self-sustaining phenomenon. The rotation of the galaxy, combined with the turbulent motions of ionized gas, acts like a giant dynamo, continuously regenerating the magnetic field. It is a cosmic engine that converts the kinetic energy of motion into magnetic energy, maintaining this fragile, pervasive force that guides cosmic rays and subtly shapes the evolution of nebulae. There are stars in the Milky Way that pulse rhythmically, variable stars whose brightness rises and falls with the precision of a cosmic clock, allowing astronomers to measure vast distances across the galaxy. The galaxy has its own heartbeat. Cepheid variable stars rhythmically expand and contract, growing brighter and dimmer over periods of days or months. This pulsation is so regular and its true brightness so well known that these stars become standard candles. By observing their pulse and their apparent brightness, we can measure their distance with incredible accuracy. They are the lighthouses of the galaxy, their regular flashes allowing us to map the shorelines of the cosmic ocean. The dust grains in the Milky Way are not just passive obstacles, they are cosmic refrigerators. radiating heat away into space and allowing dense clouds to cool and collapse to form new stars. In the dark, cold molecular clouds, the dust plays a vital role. These microscopic grains are incredibly efficient at radiating infrared light, carrying thermal energy away into space. This cooling effect is crucial. It allows a cloud to lose its internal pressure support, enabling gravity to overcome it and begin the process of collapse that leads to the birth of stars. The dust, so often seen as a blocker of light, is also a midwife to stars. The sun's motion through the galaxy means that the constellations we see today will slowly distort and change over hundreds of thousands of years, creating new patterns for future inhabitants of Earth. The starry patterns we know are temporary. The stars in a constellation are not gravitationally bound. They are simply lined up from our point of view. As each star moves on its own independent path around the galaxy, the shapes will slowly pull apart. The Big Dipper will eventually look more like a stretched out spoon. Orion will loosen his belt. The sky is a slow-motion kaleidoscope, and our familiar constellations are but a single frame in a film that lasts for millions of years. The galaxy is filled with complex organic molecules, from simple carbon chains to alcohols and sugars, frozen onto dust grains in dark clouds, proving that the chemistry of life is a natural part of the galactic environment. The ingredients for life are not unique to Earth. In the dark, cold clouds between the stars, astronomers have found a rich prebiotic chemistry. Molecules like ethanol, formaldehyde, and even simple sugars have been detected. These molecules form on the surfaces of dust grains and are preserved in the deep freeze of space. The galaxy is not just a collection of physical forces. It is a vast chemical laboratory, already synthesizing the building blocks of biology long before they are incorporated into planets. The Milky Way's gravitational pull is so immense that it affects the very structure of space-time in its vicinity, creating a gentle cosmic depression that smaller galaxies fall into. Our galaxy sits in a gravitational well, a depression in the fabric of the universe created by its immense mass. This well is like a gentle cosmic valley. The dwarf galaxies of the local group are like marbles rolling on a rubber sheet, inevitably drawn towards the lowest point, the Milky Way. Our presence warps the space around us, dictating the paths of everything that comes near, a silent, invisible ruler of our local volume of the cosmos. The light from the most distant stars in the Milky Way has been traveling for over 100,000 years to reach us, meaning we see the far side of our own galaxy as it was before the dawn of human civilization. When you look towards the center of the galaxy, you're looking not just across space, but across time. The light from stars on the opposite side of the galactic disk has been on an epic journey, traversing the 100,000 light-year diameter of the Milky Way. This light began its journey when early humans were just beginning to spread across the Earth. You are seeing a part of your own home as it was in a different age, a glimpse into the galactic past. You are, at this very moment, at the center of your own observable universe, a personal sphere of perception defined by the finite speed of light, with the Milky Way as your immediate, magnificent home. This is a profound and personal truth. The cosmos you can perceive is defined by the light that has had time to reach you. In every direction, you look back into the past, and you are the central point of this sphere of observation. The entire majestic Milky Way, with its hundreds of billions of stars, is your local environment, your cosmic neighborhood. The rest of the universe stretches out beyond, but this, here, is your home. You are not on the outside looking in. You are at the very heart of your own perceived cosmos, cradled within the arms of the galaxy. When a sun-like star dies, it does not vanish with a bang, but with a sigh, gently puffing away its outer layers to form a beautiful, glowing planetary nebula, a cosmic butterfly emerging from its stellar chrysalis. Imagine a star in its final act, not with violence, but with a serene exhalation. It sheds its outer layers into space, creating an intricate, glowing shell of gas. These planetary nebulae are some of the most beautiful objects in the galaxy, intricate tapestries of light woven by the dying breath of a star. They are fleeting, lasting only tens of thousands of years, a mere blink in the cosmic eye, before they dissipate, leaving behind the stellar core as a white dwarf. It is a gentle, beautiful end. The galaxy is filled with the faint, steady ticking of pulsars, rapidly spinning neutron stars that sweep beams of radiation across space. With the precision of atomic clocks, the lighthouses of the cosmic deep. From the remnants of supernovae, a cosmic clock is born. A pulsar is a neutron star, spinning so fast it can complete multiple rotations in a single second. As it spins, it emits a beam of radiation that, from our perspective, appears as a regular pulse. This pulse is so precise, it rivals our best atomic clocks. These ticking sentinels are scattered throughout the galaxy. Their rhythmic flashes a testament to the order that can emerge from the most violent of cosmic deaths. The Milky Way and its companion galaxies are all falling together toward a great unseen attractor, a massive concentration of mass in the universe, a gravitational pull that guides the motion of our entire local galactic neighborhood. Our journey is not random. The Milky Way, Andromeda, and all the galaxies of the local group are moving together, pulled by gravity toward a point in space known as the Great Attractor. This is a vast, unseen concentration of mass, likely a supercluster of galaxies hidden behind the dust of our own Milky Way. We are all part of a grand cosmic river, flowing toward an unseen sea, on a journey that will last for billions of years. The dust grains in the galaxy are not just cold specks. They are the sites of complex chemistry, where atoms meet and form molecules on their frigid surfaces, the first steps toward the building blocks of life. In the deep cold of interstellar clouds, on the surfaces of tiny dust grains, the universe learns chemistry. Atoms of hydrogen, carbon, oxygen, and nitrogen drift through the void and stick to these cosmic grains. Shielded from harsh radiation, they slowly skitter across the surface, meeting other atoms and forming molecules. Water, carbon monoxide, and even complex organic molecules can form in this way. These tiny frozen grains are the universe's first laboratories. The Milky Way's spiral pattern is not permanent. Over billions of years, the arms will gradually wind tighter and tighter until the distinct spiral structure may eventually fade, leaving a more featureless disk. The beautiful spiral is a phase in the galaxy's life. As the galaxy continues to rotate, the differential rotation, the inner stars orbiting faster than the outer ones, will slowly wind the arms into a tighter and tighter pattern. Over many billions of years, this winding process may eventually cause the spiral structure to become washed out and less distinct. The majestic pinwheel we see today is a temporary, if long-lived masterpiece. There are vast, empty bubbles in the galaxy's disk, carved out by the powerful winds and supernova explosions of massive stars, creating cosmic voids surrounded by shells of compressed gas. The galaxy has its own architecture of space. Around associations of massive stars, their fierce stellar winds and eventual supernova explosions blow enormous bubbles in the interstellar medium. These are low-density cavities, hundreds of light years across, surrounded by a dense shell of swept-up gas. It is within these compressed shells that new star formation is often triggered. The galaxy builds itself from the inside out, using the death of one generation of stars to create the cradle for the next. The sun's journey through the galaxy takes it not only around the center, but also through the spiral arms, a periodic passage that may have influenced Earth's climate over deep time. Our solar system does not orbit in a perfectly clear lane. Every few 100 million years, we pass through one of the galaxy's spiral arms. These regions are denser with gas, dust, and young, massive stars. Some theories suggest that during these passages, the increased density of the interstellar medium could slightly compress our heliosphere, potentially allowing more cosmic rays to reach Earth, which may have subtly influenced our planet's climate and the evolution of life over billions of years. The galaxy's dark matter halo does not interact with light, but its presence is felt in the relentless, silent pull that dictates the motion of every star and the very rotation of the galaxy itself. The true shape of our galaxy is drawn in invisible ink. The stars and gas we see are like glitter sprinkled on the surface of a vast, deep lake of dark matter. We cannot see this lake, but we feel its gravitational current. It is this unseen halo, weighing far more than all the visible matter, that governs the speed of the galaxy's rotation and holds its structure together against the centrifugal force that would otherwise tear it apart. We live in a universe dominated by a mystery. The light from the galactic center is so dimmed by dust that to see it as it truly is, we must listen with radio telescopes and look with infrared and X-ray eyes, perceiving the universe in colors invisible to our own. The heart of our galaxy is hidden behind a cosmic curtain, but we have learned to pull back that curtain, not with light, but with technology. Radio waves, infrared radiation, and X-rays can pierce the dust, revealing the vibrant, violent, and crowded center. The brilliant stars, the swirling gas, and the silent black hole are all revealed in these false colors. It is a reminder that our human senses show us only a tiny sliver of the true reality of the cosmos. The Milky Way is a cosmic ecosystem where matter is continuously recycled, from diffuse gas to stars to planetary systems and back to diffuse gas through stellar winds and supernovae in a cycle as old as time. Nothing in the galaxy is truly wasted. The atoms in your body have been on an epic journey. They were once part of the interstellar medium, then gathered into a star, forged into heavier elements in its core, and then expelled back into space in a stellar wind or a supernova blast. They then drifted, condensed into a new solar system, and became part of a planet and, eventually, you. You are part of a grand galactic recycling program that has been running for over 13 billion years. The concept of up and down is meaningless in the galaxy. We are oriented toward the galactic plane, but a star on the other side of the core is effectively beneath us, with the entire core between us. Let go of the idea of a flat sky. We are embedded in a disk, but that disk has thickness. A star that appears to be next to the galactic center from our view might actually be thousands of light years above or below it. Our perspective is that of a tiny creature on a leaf, trying to comprehend the shape of the entire pond. The galaxy is a three-dimensional ocean, and we are floating at one particular depth. The galaxy is filled with the faint infrared glow of countless cold, failed stars, brown dwarfs, and the cold dust that fills the space between the stars. A warmth that is the echo of all its light and heat. If you could see the sky in infrared light, it would not be dark. It would glow with a soft, pervasive warmth. This is the combined heat of billions of cold objects, brown dwarfs too cool to shine visibly, and the vast clouds of interstellar dust gently warmed by the starlight they have absorbed. This infrared background is the galaxy's residual body heat, a soft cosmic whisper of all the energy that has ever been released within it. The gravitational pull of the Milky Way is slowly tearing apart its closest companion, the Sagittarius dwarf elliptical galaxy, stretching it into a great stream of stars that is being woven into our own galactic halo. A slow-motion demolition is happening right next door. The Sagittarius dwarf galaxy, a small satellite of the Milky Way, is being gravitationally shredded. Our galaxy's immense tide is pulling it apart, stretching it into a long, faint river of stars that wraps around the Milky Way. This stellar stream is being gradually assimilated, its stars joining the halo. It is a live demonstration of how the galaxy grows, by gently unraveling and absorbing its smaller neighbors. The very iron in your blood that carries oxygen to your cells was likely forged in the core of a massive star that died in a supernova explosion billions of years ago, before the birth of our sun. This is one of the most intimate connections you have to the cosmos. The element iron cannot be created in the stable core of a star like our sun. It can only be forged in the final, furious moments of a massive star's life during the silicon burning process just before its supernova explosion. That iron atom was then blasted across space, eventually finding its way into the cloud that formed our solar system, and billions of years later, into you. You carry the legacy of a stellar giant's death within you. The Milky Way's rotation curve, the graph of orbital speed versus distance from the center, is flat, a key piece of evidence that most of the galaxy's mass is invisible dark matter, extending far beyond the last visible star. If the galaxy were made only of the stars and gas we see, stars at the outer edges would orbit much more slowly, like the distant planets in our solar system. But they don't. They orbit just as fast as those closer in. This flat rotation curve is the ghostly signature of dark matter. It tells us that the visible galaxy is just the bright tip of a much larger, much more massive, and completely dark iceberg. There are stars in the Milky Way that are nearly as old as the universe itself, silent witnesses to the galaxy's entire history, from its chaotic formation to the present day. In the halo of the galaxy, there are stars that have been shining for over 13 billion years. They formed when the universe was in its infancy, from the primordial gas of the Big Bang. They have witnessed the Milky Way's violent youth, the accretion of its disk, the birth and death of countless stellar generations. They are the galaxy's elders, holding in their simple, pristine composition the secrets of how it all began. The solar system is tilted by about 60 degrees relative to the galactic plane, meaning we orbit the galaxy at a steep angle, bobbing up and down through the disk. Our orientation in space is askew. The flat plane of our solar system, where the planets orbit, is tilted at a sharp angle compared to the flat plane of the galaxy. This means that as we orbit the galactic center, our path is not a smooth circle within the disk, but a wave-like motion that carries us above and below the galactic equator. We are like a ship sailing on a rolling sea, rising up and dipping down on a journey that lasts 250 million years. The galaxy is not a closed system. It loses material as fast-moving stars and gas are ejected by gravitational interactions and through the gentle but continuous pressure of starlight itself. Just as the galaxy gains material, it also loses it. High-speed gravitational encounters can fling stars out into intergalactic space. Furthermore, the sheer pressure of light, the momentum of photons from bright, massive stars, can push tenuous gas out of the galaxy, especially in regions of intense star formation. The galaxy breathes in, and it also breathes out in a slow cosmic respiration. The Milky Way's vast scale means that any message, any signal, any physical object would take tens of thousands of years to travel from one side to the other, ensuring a profound and enduring silence between its far-flung regions. The speed of light, while incredibly fast, is finite. A signal sent from a hypothetical civilization on one side of the galaxy would take over 100,000 years to reach the other side. This immense gulf of space and time means the galaxy is, for all practical purposes, a collection of isolated islands. The distances ensure a permanent, deep quiet, a separation so vast that the left hand may never know what the right hand is doing. The galaxy has a past that is still being uncovered, written in the motions and compositions of its stars, a story of mergers, bursts of star formation, and quiet periods of equilibrium. The Milky Way's history is not a single simple story. It is a complex tapestry of events. By studying the motions and chemical makeup of stars, astronomers can read this history. They see the evidence of past mergers with dwarf galaxies, epochs of frantic star formation, and long, quiet periods. Our galaxy has a biography, and we are only now learning to read its early chapters. The force of gravity that sculpts the galaxy operates at the speed of light. If the sun were to suddenly vanish, the Earth would not fly off into space for 8 minutes, and the galaxy would not feel the loss for 25,000 years. The news of a gravitational change travels no faster than light. If the sun disappeared at this instant, we would continue to see its light and feel its gravity for 8 more minutes. On a galactic scale, if a massive object at the center vanished, the stars at the outer edge would continue in their orbits for tens of thousands of years, completely unaware. The fabric of space-time tells its story slowly, with a cosmic delay that dwarfs all of human history. The Milky Way, for all its complexity, is ultimately a simple gravitational structure, a self-gravitating collection of matter obeying the same laws of physics that operate in this room right now. The majestic spiral, the swirling gas, the orbiting stars, it all boils down to one fundamental force: gravity. The same law that causes an apple to fall from a tree governs the motion of a star around the galactic center. The galaxy is not magic. It is physics operating on a grand scale. Its beauty lies in the emergence of immense complexity from a simple universal rule. The galaxy is evolving. The rate of star formation has peaked and is now in a long, slow decline. As the available gas is gradually used up and locked away in long-lived, low-mass stars and stellar remnants. The most active era of the Milky Way's life is behind it. Billions of years ago, star formation was more furious, fueled by a richer supply of gas. Now, that gas is being depleted. Much of it is locked in stars that will shine for trillions of years, or in the white dwarfs, neutron stars, and black holes that are the endpoints of stellar evolution. The galaxy is settling into a quiet, mature age, its brilliant star-forming fires slowly burning down to embers. The future of the Milky Way is one of merger and transformation, first with Andromeda, and then with other galaxies in the local group, until it becomes part of a larger, elliptical galaxy, a new cosmic entity. Our galaxy's story is far from over. Its destiny is to merge with its great neighbor, Andromeda. This will trigger a burst of new star formation, fundamentally altering both galaxies. Over even longer timescales, this new, larger galaxy may merge with others in the local group. The distinct spiral shapes will be lost, blended into a more featureless, elliptical galaxy. It is the end of one identity and the beginning of another on a timescale of billions of years. And the final fact, the one to carry you into sleep, is that you are a part of this galaxy. The calcium in your bones, the iron in your blood, the oxygen in your lungs, all of it was forged in the hearts of stars that lived and died within the Milky Way. You are not just looking at the galaxy. You are the galaxy, experiencing itself. A conscious collection of its stardust, resting on a small, beautiful world, nestled in the quiet Orion Spur, under the silent, starry veil of your cosmic home. And so, we have reached the end of our 100 facts, 100 glimpses into the infinite nature of our galactic home, 100 quiet thoughts to drift away with. You have journeyed from the local Orion Spur to the warped outer edges, from the brilliant spiral arms to the silent, dark heart. Your mind has expanded to hold the vast rotations, the deep time, and the silent, recycling nature of the Milky Way. And now, it is time to let it all go, to release these facts, these wonders, these names. They have done their job, gently occupying your thoughts, easing the transition from wakefulness to sleep. Feel the quiet weight of your body on the mattress, the softness of the sheets, the gentle rhythm of your own breath, in and out. The galaxy is vast, but in this moment, your world is small and safe and warm. The stars will continue their slow turn along the Milky Way. The spiral arms will continue their stately rotation. The light from the galactic center will continue its long journey through the dust. And you can rest. You are stardust. You are part of this magnificent spinning galaxy. And as you sleep tonight, the Milky Way continues its beautiful, silent dance, with you as a cherished part of it. Let your breathing slow even more. Let your thoughts dissolve into dreams. The galaxy is watching over you. It is always there, a constant, gentle presence, the river of light in your sky. Sleep now. Dream of spinning nebulae and quiet cosmic drifts. Dream of floating along the spiral arms. Good night.